Today, I just want to share with you the progress of a project that started last year and funded by AgriFutures. And the experiment I'm going to present in this presentation is a collaboration with the University of Arkansas with Dr. Mike Hitt and Mr. Craig Maynard. So I would like to thank my co-authors and also my collaborators. Okay, so just to give you an overview of this project will include 4 studies. We're aiming to look into fundamental problems in reduced crude protein diets. So it includes 4 studies, and the first 2 studies we would like to identify the optimum ideal protein ratios in reduced crude protein diet. Facing 2 challenges in the literature. So most amino acid requirement studies were done in conventional diet in male birds only. And also, if you look into it, most of these studies do not measure digestibility or confirm digestibility of amino acids. And the recommendations provided by breeder companies is largely based on historical data in the nutritionist database. So it's quite frightening when you think about that. So we're going to revisit ideal protein ratios. We hypothesize that there will be difference in conventional diet and the reduced crude protein diet in terms of ideal protein ratio. So study 1 at the moment is running, and we will harvest the data in 4 weeks' time. And then third study is a ring study, is a parallel studies run both in the University of Sydney and also Arkansas, and that's the study I'm going to present in details today. And then the final study, we want to look into the optimal energy because a synthetic or crystalline amino acid does not require digestion as much as conventional protein ingredients. And we hypothesize that there should be room for us to reduce energy in the diet, and also at the same time to help improve the carcass composition. I have to say, the final study, we will not just look at one phase at one time. We will look at the starter, grower, and the finish at the same time by using box banking design. So I'm quite excited about that opportunity. So today we're going to focus on objective 3, so study 3. And we have completed this study or the design in both facilities at the University of Arkansas and the University of Sydney by using different birds and also different type of diet. So this is a method this is a deletion method we're using, and we try to identify the most valuable synthetic amino acid you want to add into your reduced crude protein diet. We understand the existing feed mills limitation to adapt reduced crude protein diet is the number of beans you can use. So it will be very handful if we produce a batting order of the importance of different synthetic or crystalline amino acids. So in order to do this, we had 13 dietary treatments. So the first 3, they are controls. We have an industry control, which is a conventional diet, 21% crude protein at the Camden study, and then around 20.3% crude protein in the American study. So, and then next we have positive control, which is a reduced crude protein diet. Then we add crystalline and synthetic amino acid back to the industry control diet level. Then negative control is basically positive control, and then we take out all the added amino acids except the lysine, threonine, and the methionine because they're already routinely used in diets anyway. And then the subsequent 10 treatments, we delete amino acids 1 at one time. So we're taking PC diet, and then we just do the 1 at one time. And all the others are the same as PC diet. So we hypothesized that the PC diet should perform as good as an industry control diet. And then the NC diet, we should see a significant drop of performance. and the subsequent 10 treatments somewhere in between. That's our hypothesis. But you're always surprised by experimental outcome, which is the joy of doing research. So this is the dietary composition of the diet we used in 2 facilities. We used commonly locally available ingredients. So in Australian study is a wheat-based diet, wheat, canola seed, soybean meal-based diet. And in the American study is a typical corn and soybean meal-based diet with lots of added amino acids, as you can see. Oh, and also this is for birds from 14 to 35 days. Should have shown that before I show you the nutrient specification. And also there are other differences in these 2 studies. So we used a different bird, and again the same, we used the off-sex male Ross 308 from the female line, female parent line from Goulburn for the Sydney Uni study. And but in the University of Arkansas study, and we used the COP and V500 fast feathering birds. Slightly different stock density, but not too much difference. Right, results. So it's very interesting to see birds responded differently. I have to say there are 2 variables here. One is type of diet, the other one is type of birds. So let's just look at the Australian study first. As we expected, positive control diet performed similar, had the same. Broiler chickens offered positive control diet had a similar weight gain in comparison to industry control diet. But if you take all the added amino acids out, except lysine, methionine, and threonine, the weight gain dropped significantly. Well, interestingly, if we take PC diet, only take out the valine, weight gain dropped even further. So that means it's not very smart to, in order to cut the cost, to only take 1 amino acid out. You'd better just take all of them out if you want to. So that's very interesting itself. And then isoleucine, also significant damage in comparison to positive control, and then leucine as well. All the rest very similar, I should say statistically similar, weight gain in comparison to PC diet. So this emphasizes the importance of when developing reduced crude protein diet, we really need to look at the branched chain amino acid, understand more the interactions and antagonisms between them. Well, in the American study, I didn't show the performance of industry control diet here because that wasn't done in the same experiment because of the facility's capacity. So we ran the first study and compare just the IC, PC, and NC diet to verify our hypothesis. We did see PC and IC no difference. At the end of this presentation, the final slides, I actually put the reference there. The paper has already been published. So if you're interested in the details, you can see, you can go through the paper. Okay, interestingly, so taking out valine, it still significantly depressed the weight gain. But here, PC and NC, it did not really see very big drop, which kind of what we expected. Again, we think that's the difference between weight-based diet and the maize-based diet, but it could be Ross and the cod birds as well. Yeah. So, and then except valine, all the other amino acids, when you take it out, statistically, they had the same weight gain in comparison to positive control. So FCR, similar story. Branched chain amino acids still, they are very important. Positive control diet had numerically the best FCR, but very close to the conventional diet. Well, take all of them out, significantly damaged feed conversion rate, feed conversion efficiency. And then, so taking out isoleucine actually did the most damage if we just look at the treatment with a single amino acid taken out. And all the rest, statistically similar to positive control. All right, again, importance of very, very important branched chain amino acids. And then in the University of Arkansas study, interestingly, is quite different observation. So not sure what's going on there. So isoleucine, taking it out, actually the feed conversion ratio did not blow up, actually improved. So, and all the others had no significant difference. Oh, sorry, I mean, taking valine and leucine out actually did not have significant impact on FCR in comparison to positive control. So very different. Breast yield. So in an Australian study, so similarly, statistically positive control and industry control had no difference. And the taking out branched chain amino acid significantly compromised the breast meat yield. And so all the others had a similar or no impact, or a slightly small impact or no impact on breast milk. So histidine they also did, taking it out also did some damage on breast milk yield, but not as profound as in the treatment when we take branched chain amino acid out. So so leg quarters, we can have a quickly look at slightly different cuts because of our capacity are quite different. So again, taking out histidine did big damage. It's very interesting when you take out valine, the yield actually increased a bit, which makes sense because it's either leg quarter yield or a thigh yield or breast milk. Because the breast milk yield dropped, then of course in percentage terms, and the leg quarter yield increased. No significant difference there for the University of Arkansas study. So this is the conclusion of the observation. So wheat-based diet are more sensitive to dietary amino acid changes, but it could be due to we use the raw spurs in Australian study as well, because I know the common view in America is raw spurs is more sensitive to amino acid changes, or cobbers are more resilient to amino acid changes. Branched chain amino acids are very important when you want to get it right. And the glycine also shows a significant impact on FCR in wheat-based diet only. And again, I think some nutritionists already pay attention to glycine. So, and it's commercially available anyway. All right, so the attention to take is conclusions, especially the recommendations of amino acids requirements by breeders, most of that done in corn-based diet, or studies in the literature, most are done in corn-based diet. So that doesn't apply in wheat-based diet. So we just need to read it with caution. And also, it's definitely necessary to conduct a more locally relevant animal nutrition studies. So that's all about me. The reference is on your left, and also sponsors are on the right. Thank you very much.